Hey guys, welcome to another video for math. In this video we're going to be covering a calculus topic. This topic is extreme value theorem, and it states that if a function f is continuous on an interval, a closed interval a, b, then the function attains both a maximum and a minimum on a, b. And in this video we're going to explain what this means. So let's go ahead and get started. So the extreme value theorem, as you can see it on that graph that I have here, so I have an interval, I'm going to highlight it, interval A and B. So I have two points there. And the graph, so on this full function, on this graph, what this theorem says that on this interval from A, and I'm tracing all the way down to my point B, on this interval, or the highlighted part, the red part of the graph, it says that if a function is continuous, and this function is continuous, in that closed interval, there should be both a maximum and a minimum. So, if as you look at the function, all you got to do is find the lowest point, which on this graph, I'm going to highlight in green. It's this point right there. That's the minimum. And then you locate the highest point. And as you trace in the graph, you can actually see that that point right there is the maximum point. And that's all that's saying. So, I'm going to work out one of the problems in the book, this one right here. And now this problem, the difference between the problem and my definition of the extreme value theorem is that the extreme value theorem was nice enough to give us a graph so we can get a visual. In this case, we don't have a visual. We just have the function. So now, the easiest way to find the maximum or the minimum on a closed interval is to find all the places your extreme values are going to be found in all the places where the slope is going to be 0. Now I'm gonna go back to the graph real quick. Now you notice here, if I find the instantaneous velocity or the instantaneous speed at this particular point, and remember what that means. That means that's the tangent line, right? So if I find the tangent line of that point, you'll notice that the slope is pretty high, right? And as I keep going down, the slope is pretty high. Same thing, the slope is pretty high. But the closer I get to that minimum point, you'll notice that the slope actually starts to flatten out a little bit until I get to that minimum point, and then the slope flattens out completely and it becomes 0. And then as I go past that point, my slope begins to slowly rise again, right? And then as I get close to another point where my graph is kind of taking a loop, it's going up and then down, that point is also going to have a 0 slope. But that's not a maximum point. The maximum point is over here. And this slope is also going to be 0. So in the interval, any places where I have a 0 slope, all right, any places that have a 0 slope, that's going to be the location of my minimum or maximum point. And you're not going to necessarily know if it's a minimum or maximum point until you do a little bit more math, and we'll get into that using this problem here. So again, I want to find my tangent lines, right? My instantaneous velocity, if you remember. So I want to find where my tangent lines are 0. So in order to find where that tangent line is, I need to find the derivative of this particular function. So I need to first find the derivative of this, okay, and I'm going to use my shortcut. So I know that this is, I take my exponent, multiply it into my coefficient, I end up with 4x, and then my exponent minus 1 gives me 4x, and then plus, and then over here this is exponent 1, so 8 times 1 is 8, 1 minus 1 is 0, x to the 0 is just 1, so this is my derivative. Now, the next step from this point is, again, I want to find where my, I know this is really messy now, my graph is, but I want to find where my tangent line is 0, where my slope is 0, because that every time I find it where it's 0, that tells me where the graph is going up, or where the graph is flatlining, where the tangent line is, when there is no slope. Right, and that tells me where the maximum and minimum point are. So let's go ahead and find that. So f of x, I need that f of x to equal 0. So 0 equals 4x plus 8. And then I'm going to go ahead and just do my math here. So I end up with negative 2x. So at negative 2 on my graph, I'm going to draw my graph here. At negative 2, there is a minimum, there is a critical point. Okay, I have found the location of my critical point, but I do not know if it's a maximum or a minimum. Well, on my graph here, I was given an interval, right? So I need to find out how I need to plug in over here. Let me just plug it in on my graph. So I have negative 5, and then I have 0. So that's the area of the graph that I'm paying attention to. So to give me more of a clue as to how this graph looks like, I want to plug in these points. I'm going to highlight them in yellow. These points, I want to plug these points into my derivative function. Or actually, sorry, not my derivative function, but my actual function, right? All right, so let's do that. So I'm going to find where f of 5 is. F of 5 is 2 times, and I replace 5 wherever there's an x, 5 squared plus 8 times 5, right? So wherever there was, here, let me erase this part here. Wherever there was an x, I'm going to highlight it in green. Wherever there was an x, I'm replacing with my 5. And then I'm going to find out what that is. So that's 25 times 2, that's 50, plus 40, plus 40, actually this is negative 5. Yeah, it's negative 5, not just 5. Plus 40, so that's negative 20, that's 25 times 250, plus 40. Okay, actually, nope, that's minus 5, so that's 8 times negative 5, which is negative 40, that's 10, sorry. So just to rehash, that 5 was supposed to be a negative 5, which would make sense because it's right here, negative 5 and 0, right? So negative 5 times 8 is negative 40, negative 5 squared is positive 25, times 2 is 50, 50 minus 40 is 10. So at negative 5, my f of negative 5 is 10. So then that's where this point is. Okay? All right. Now let's find what my f of 0 is. F of 0, so that's 2 times, anywhere there's an x, I replace it with 0. 0 squared plus 8 times 0. And that's going to equal 0, right? So f of 0 is 0. So that's where this point is. So, still doesn't really tell me. Now, actually, what I want to find, the next point I want to find is negative 2 itself, right? What is negative 2? So I want to do f of negative 2, 2 times negative 2 squared plus 8 times negative 2. So negative 2 squared is positive 4 times 2 is 8 plus 8 times negative 2 is negative 16, so that's negative 8. So f of negative 2 is negative 8. So I'm now going to plug that into my graph. So negative 8, so negative 2. So now you can see, now I'm going to kind of connect the dots here. So from negative 5, 10, I connect my dot there, and then I stop there. And that's my interval. That's the only part of the function that I need to pay attention to. So the question for this problem was, number 1, here, let me clean this up a little bit so I can write my answer on this space. I'm going to write it in red. I need to find my critical point, and I did. My critical point was at negative 2, negative 8. And again, when I found that critical point, I didn't know if it was a minimum or a maximum. But by plotting these other 2 points from my interval that was given over here, when I plotted those 2 points, that gave me an idea as to what that was. And as it turns out, this point right here was a minimum. So then my minimum is negative 8. Okay? And then my maximum, so now I just got to look at my graph. I got to look at my graph and where is the highest point? Well, my highest point was at negative 5. All right? So in the closed interval, let me clean it up a little bit. take the highlighting off. In the interval -5 to 0, I have a critical point at -2, -8, and that's the minimum, the -8, and then my maximum for this particular, at this interval, is at -5. Okay, let's work out one more problem that's like this.